So let's find the product moment of inertia for this triangle right here. We'll go to the next slide. Just remember B is the width, H is the height, and here is the expression in terms of the parallel axis theorem for center of mass. Center of mass would be 2/3 B and 1/3 H. We can look that up in the back of the book. Okay, the way we need to analyze this is we're going to be integrating from x equals 0 to b. There's the integral right there. And we'll take this rectangular element, height y, width dx, and the moment of inertia about the center of mass of this element is the product moment of inertia is going to be 0 because it's symmetric. And we talked about that. If there's a center of symmetry in the object, dxy is 0. The center of mass, so we just need to worry about the center of mass. Where is the center of mass? Well, it's at x, the location x, and it's at y/2. So here's the x location of the center of mass, the y location of the center of mass. That's dx and dy, not differentials, but d subscript x, d subscript y, that we would plug into our parallel axis theorem formulas. And then we need to know a. Well, that's just y dx, the height times the width. And we simplify everything using this expression. So here's y dx x y. We can get h squared over 2b squared out, and we've got 1, 2, 3 x's, x cubed dx. Integrate it. So that'd be h squared over 2b squared times x to the 4th over 4. Or b to the 4th, I should say, since we're evaluating it from 0 to b. And so we'll have h squared b squared. There's the h squared b squared. B to the 4th cancels out 2 of the b's, cancels out b squared. So you just have b squared on top. B squared, h squared, and then the number 8. So that's the formula. The other way to do it is integrate from y equals 0 to h. Very similar analysis, except it gets a little more, you'll notice the formulas are more complicated and harder. So let's do it the easy way. Let's not even go with solution 2. Let's skip solution 2. It's harder. It's tedious math. Same idea. You'll notice di x prime y prime is 0, just like before. It's just these center of mass expressions are a lot harder. Do it the easy way if you can. So let's find the moment of inertia of this right here. Now, number A, so we're locating the center of mass. So that's at number A is 200 millimeters above the x-axis. It is 250 millimeters to the left of the y-axis. D is 250 millimeters to the right and 200 millimeters below the x-axis. So we can write down relatively simple formulas. So IB, xy, well, IB is 0. So it's just IA plus ID. IA, and just to remind us, it's the product moment of inertia. And just like before, the product moment of inertia about the center of mass of both A and D are 0 because the center of mass is on a line of symmetry. So to get the moment of inertia, we just need to take the area, which is width times height. B is the width. I'll take B as the width. B equals 100 millimeters. Height, H equals 300. So it's just the area, B, H, times the distance the center of mass is from the x-axis, and the distance the center of mass is from the y-axis. So I'll just leave it in formula form, dx dy. And we multiply it by 2 because we have A and D. We have, yeah. So one thing to notice is we got to pay attention to our signs now. Dx is negative here. Dy is negative here. So we got to have the negative signs. Negative twice. There's 2 of them. They're both going to be negative. Dx, dy. This is dy, 250 millimeters. Or excuse me, this is dx. 200 millimeters is going to be dy. Yes. And the area, which is BH. Okay, let's go ahead and move on, see what the book tells us. Just like we said, BH, and I forgot which one is B, and B would be the 100, H would be the 300. There's that negative sign, dy and dx. So that's rectangle A only. The book is showing you rectangle A only. I put in both rectangles, so for both rectangles it should be -3 times 10 to the 9th millimeters to the 4th. There it is. There's the final answer.